Hello students, welcome to the class of Technomathematics. So today we will be solving some questions from vector. Instead one question. The question is that calculate the area of the parallelogram whose adjacent sides are given by the vector A and B as shown to you. Right. So the vector A is given to you as I plus 2j plus 3k and vector B is given to you as 2i minus 3j plus k. Right. So these values are given to you. We need to find the area of the parallelogram whose adjacent sides are these vectors A and B, right? So the vector A and B. So A and B are the adjacent sides of that parallelogram, right? You know what is a parallelogram? A parallelogram is a closed figure with four sides whose opposite sides are equal and parallel to each other, right? So let me show it over here. Yeah. So if this is one of the side and this is second side and as adjacent, that means both these sides are just attached to each other and nearby. Those sides are called adjacent sides, right? So here A and B are the adjacent sides represented by the vector A and vector B. Now the area of this parallelogram, right, is calculated by the cross product or the vector product of these two vectors A and B, right? So the cross products of A and B, instead not its area, the magnitude of that cross product will give you the area of this parallelogram, right? And that we need to calculate, and it's very easy to calculate. Let us see how. So the cross product of the vectors A and vector B, both these vectors will be giving you the area of the parallelogram, instead the magnitude of the cross product, right? So here how to calculate the cross product, let us see. Just use the determinant format. Here I, j and k, right? These are the unit vectors along I, j and k direction, and just put up the value of A, that is the component of I, j and k just under the I, j and k values. Here you can see the component of I for vector A is 1 and j is 2 and 3 for k. So 1, 2, 3 is placed under I, j, k for vector A. Similarly 2 minus 3 and 1 is placed for the I, j, k component for vector B, right? Now since the I component, that means I will be 2 into 1 minus 3 into 3, right? This will give you the I component of the cross product, plus j component will be given as, you can see, 3 into 2, right, minus 1 into 1, right? This will give you the j component, and the k component is given as, just leave the column and row for the k, and what are the numbers which are left, right? That is 1 into minus 3 minus 2 into 2, right? So leave that row and the corresponding column for each of the unit vectors, right? So finally we get the value of I, the constant term with I is 2 plus 9, and for j is 6 minus 1, and the constant term with k is 1 into minus 3 is minus 3 minus 4, right? Now the next value will be 11i, so it will be coming as 11i plus 5j minus 7k. So this is the cross product, right? But this will not give the actual area of that parallelogram. The area of the parallelogram will be the magnitude of this cross product. So what is the magnitude of this cross product A and B of the vectors A and B? cross product of the vectors A and B is calculated. Now calculate the magnitude of that cross product. That means the magnitude is calculated by root over of 11 square plus 5 square plus minus 7 square. So 11, that is the constant with the I and constant with j and constant with k. Just take a square root. Under the square root, take a square of all these three terms, and this will give you 11 square is 121, 5 square is 25, and minus 7 square is 49. When you add all these together, 121 plus 25, 146 plus 49, so this will give you 195. Yes, 195. So root over 195 square units, right? Because it's an area, so it will be, the unit will be in a square, right? Whatever the unit, but it will be in a square. It will be in a square. So this will be the area of the parallelogram whose two adjacent sides are given by the vector A and vector B as given into the question, where vector A is I plus 2j plus 3k and vector B is 2i minus 3j plus k, right? So root over 195 is our answer, that is area of parallelogram.